Okay, so I want to do a review for orthogonal diagonalization. That's the topic from 7.2 that we did. And so the question will be, I'll give you 2 by 2 matrix. I told you only 2 by 2. And I want you to orthogonally diagonalize. And I might or might not do an extra credit where I ask you to calculate the power of A using this orthogonal diagonalization. Okay, I'll explain another thing. So first of all, let's focus on the main thing, the orthogonal diagonalization. So step 1, of course, we need the eigenvalues. I took a little bit bigger numbers to show you that, okay, it's a 2 by 2, so it's not that much work, but still. So the characteristic equation will be 17 minus lambda, 9 minus 7 minus lambda. So that would be 17 minus lambda times minus 7 minus lambda minus 81. Now, as I said, the numbers are a little bit big, so we have to multiply them. 17 times minus 7, so I'm expanding, that is minus 119. Then minus 17 lambda plus minus 17 lambda plus 7 lambda plus lambda square minus 81. So minus 119 minus 81 is actually, well, let's write this one first, lambda square. Then the powers of lambda, that is minus 10 lambda, and then these two together, that is actually minus 200. Okay, so we need two numbers. To factor this, we need two numbers that multiply to negative 200 and add up to negative 10. Okay, so you have to think a little bit about this, but I think 20 and 10 will work here. Let's think about what we need then. We need negative 20 plus 10. Okay, if you don't see this right away, the numbers are a bit bigger, as I tell you, you can always use the quadratic formula, right? So I remind you the quadratic formula is b squared plus minus radical. Sorry, I got confused. So the quadratic formula is minus b plus minus b squared minus 4ac divided by 2a. So in this case, this would be 10 plus minus 100 minus 4ac, that is plus 800. Okay, minus 4 times minus 200, okay, divided by 2. Now that is 10 plus minus, this is 900, the radical of 900 is 30 divided by 2, so you find two possibilities. 40 divided by 2 is 20, and 10 minus 20 divided by 2 is minus 10. So that's what we got here. So this lambda is 20, lambda is minus 10. Oh, minus 10. Okay, so step 2, the eigenspaces. Let's do lambda is 20 first. So we subtract 20 from the diagonal. We get minus 3, 9, 9, and then minus 27. Okay, not so bad. We can make a 1 in the first row by dividing the first row by negative 3. So we get 1, negative 3, and then 9 minus 27. And of course, what now needs to happen, otherwise I made a mistake, is that the row operation, that using this pivot here, should get me a 0 row. That's the case, right? Because that's 0, and if I multiply this with negative 9 and add up, then I get 27 minus 27, that is 0. Sorry, I can, 1, negative 3, then 0, 0. Okay, so let's analyze everything. This is our pivot variable. We have a free variable, that's x2. So x1, x2. x2 is just itself, and x1 is 3 times x2. So we find the eigenvalue 3, 1. Basis for the eigenspace, sorry, eigenvector. Okay, so we need to normalize, that's the extra step that we need to do. And so that means we need to calculate the norm of this fellow, and that is square root of 3 squared, that's 9 plus 1, so square root of 10. So the basis vector that we will take is Remember, we divide now by radical 10, so I'm going to already do it right away. Okay, that's our first basis vector. That's for lambda equals 10. 20 for lambda equals to negative 10, so that means now we're adding 10 to the diagonal, that would be 27, 9, and then 9, 3. Here you see we cannot really get an without getting fractions, but okay, it's not so bad, so I'm going to divide the first row by 27. Looks worse than it is, so because we get 1, and here we get 9 divided by 27 is 1/3, and I get 9 and 3. And so now the second thing that I want to do is go to minus 9 times row 1, and that is exactly what I want, right? Because this is going to give me a 0 here, and then this, if I multiply this with 9, with negative 9, that is minus 3 plus 3, that is 0. So I get again what I wanted. Okay, so this is my free variable x2, x1 is a pivot variable. Let me not mark this anymore. So x2 is equal to itself, and x1, well, let me mark it here. So this is x1. x1 is equal to minus 1/3 x2. So our vector that we have now, our basis vector is minus 1/3, 1. We could get rid of the 3, but we have to take a norm anyway, so let's just take the norm here. And then divide by that now, minus 1/3, 1. So that would be the square root of 1/9 plus 1. Okay, that is the square root of everything on common denominator 9. That is 1 plus 9 nines. And the square root of 9, of course, so this is square root of 10 divided by square root of 9, which is 3. Okay, so our basis vector, so this is the normalization that I did, right? I did write it down, normalization. And so I find the basis vector is 1/3 divided by this, so multiplied with the reciprocal of that guy, and then, oh, minus 1. And then 1 times the reciprocal of this guy, so 3 over radical 10. And notice that the 3's here cancel, so we get actually minus 1 square root of 10, 3 square root of 10. Okay, so we have everything. So the last step really, if for orthogonal diagonalization is, what is P? Well, P are my basis vectors, right, that I have, and D is the corresponding matrix. I put 20 first and then minus 10 second, so that's what I get. And P is, where is P? Where are my basis vectors? This one is here, 3 radical 10, 1 radical 10, and then here it is minus 1 radical 10, and 3 radical 10. And that's all that you need to do, right? Because this guarantees us that P inverse, I'm going to write inverse, but I'll replace it, P is equal to D, but we know that P inverse is the same as P transpose, right? The inverse of the matrix is equal to the transpose of the matrix, because, sorry, let me make this a bit more neater. This is an orthogonal matrix, and this means exactly that we have this. Sorry, I'm being sloppy here, minus 1. Okay. Now I'm writing it this way because remember, so the extra credit problem, I have to write this the other way, right? I have to bring the P and the P inverse to the other side, so I get P, D, P inverse. Now in our case, inverse is transpose, so it is P, D, P transpose. Okay, just wanted to show you that that's how things go. Okay, so the radical question, I had to find a cube, I said, right? Yeah, because I mean the numbers are rather big, so I don't want to make too big a thing. Yeah, a cube. So a cube, we know now that's the same as B D cube transpose, P transpose. So that's why I'm writing this. Now P, remember we have this, we can actually write it as 1 radical 10 and then 3, 1, minus 1, 3. It's easier to write it this way. And then so we have 1 radical 10 to work with it, right? Otherwise these radicals is very bad, they distract you completely. So that is that. Now D cube, what is D? Now we have to cube this. So 20 cubed, okay, think a little about it, it's really 1000. Okay, it's a big number, but okay. And then minus 10 cubed, it's minus 1000. Correct? Okay. And then what is then the transpose? Well, this transpose of this guy. Now remember, there is a radical 10 here, and then we just transpose this, and that is 3, negative 1, 1, 3. So let's bring the 1 over radicals out. So get 1 radical 10 and 1 radical 10 altogether is 1 over 10. And then we have 3, negative 1, 1, 3. Oh, and so, yes, so, sorry, that's what I want to say. Now, there's 1 over 10 we can now bring inside here in the I-1000, right? As I said, we move numbers, scalars can be moved around in this product. Not the matrices, but the scalars. But a scalar, what this always means that you multiply a matrix with a scalar means every single entry has to be multiplied. So here we can get the 1/10 in here so that we divide everything by 10 here. So we get this. Okay, so now we're got rid of this one. Okay, let me redo it because you might got lost a little bit what I'm doing. Okay, so this is what I had, right? Sorry, let's write it out because I might confuse some of you. This is by bringing these two guys in front and make it 1/10. And now I'm bringing this guy in here so that I divide everything by 10 in here. So what we get is, I'm going to do this now on the thing here because otherwise it takes too long, right? So this, okay, let me do it in another color. So this becomes 800 and this becomes minus 100, I divide by 10, and then this is gone, okay? So I'm doing this so that the calculation is slightly easier now. I don't have to deal with fractions anymore. Okay, so let's do this one first. We multiply with 800, so that is 2400, 800. And then in the bottom we multiply with a minus 100, so that is 100, and that is 0, minus 300. Okay. Now, okay, so we have 3 times 2400, that is 7200 minus 100, so 7100. Okay, then we get 2400 plus 300, that is 2700. Then we get 2400 plus 300, 2700. This better be symmetric, right? So that's going in good shape here. 800 minus 900, that is minus 100. And so that is the cube of my matrix A. And you see it's relatively easy to do, but the big numbers indicate that if I would have to work it out, it would take me some time, right, to do A cube just by hand, although it's only a 2 by 2. So this method, still for 2 by 2, might not be really paying off, but for higher order it would be, but I'm not going to do any higher order. Okay, so that's the review.